Hi everybody, welcome back to the track number 7 of your developments in artificial intelligence applied to supply chain, more specifically in container port operations. My name is Anibal Azevedo, and now in this track we're gonna perform the final adjustment to incorporate quake cranes operations in a optimization approach. So, what's important now? We're gonna review what we saw in the previously tracks and gonna understand what is the development that we're gonna make in this track. So let's start to show the presentation here. So we're gonna modify the genetic algorithm that we developed in the previously tracks. And now we're gonna see what is the importance or why this is should be done in this track. So let's see what we have here is the objective of these tracks, the series of these tracks, is just to prove or to show in more detailed fashion how you can apply artificial intelligence techniques in the context of container ports. So in the track one, it will appear a car somewhere. We saw how we can develop a class to represent the space of a container ship, and this is important because we can use this to understand how many movements or how certain actions will impact in the organization of a container ship. So we made a simplifier representation, but very useful representation of a container ship. In the second track, we talked about how you could load or unload containers in a container ship by using some functions, loading and unloading rules functions, and different kinds of loading rules will have the impact in the long range of the container in this travel through ports will have a different way to fill the container ship and has different impacts in terms of stability and number of movements. Also, we made a very detailed coding of the rules functions. Then this could be avoided in a future track, in a track number 8. We will show how you could avoid this. And in the track 3, we talked about how we can use the previously tracks to make a container ship simulator. So what's important that the ship will perform application of series of rules, unloading and loading rules through ports, and this will result give us the result of in terms of number of movements or stability. You can show how the application of different rules will produce different numbers in terms of number of movements and can save money. Okay, so you can say that we have a chain of rules, okay, that we are gonna apply through ports, since you have some unloading and loading rules. But this is the only this is the simplified version of the simulation that we developed by using unloading and loading, and this is important because use as a parameter of unloading and loading functions the rules that we developed to unload or load containers inside a container ship. Okay, in track 4, we talked about since we can have a very hard combinatorial problem because we can have many combinations of rules, unloading, loading, and even retrieving. If you are retrieving containers from the storage yard, or if you are applying some quay cranes rules, if you can incorporate more equipments and more rules. So this combination of rules in each port can be very big, and then if you have to make decisions in series, you can have more possibilities of rules, more combinations of rules. Then we should apply. It will be a very good idea to apply a kind of genetic algorithm that use this information of what combination of rules should be applied in each port, and you can test this. The evaluation will be according to a simulator that we made before in previously tracks. So what is missing? We can incorporate in this simulator the quay cranes operation. So the quay cranes operation should be careful because cranes are very big structures that are that have a dimension of a building, and you have to keep some minimal distance for security reasons, and also you could this rail mounted equipments could not overlap the other ones, so you have a specific dynamics here, and you can also you should use these dynamics if you are interested to account in detail how much time you're gonna use to perform some quake cranes operation. Okay, so we developed in this track, the track number 5, we developed the rules to operate two quake cranes. We can generalize this procedure to as many quake cranes as we needed. So, but what is most important, this is a simple function that gives us a correct expectation of how much time will be spent by the joint operation of these two quay cranes. After this, we have to employ this joint operation of quay cranes rules inside the quay crane, the ship container ship simulator. So we made a joint simulator of a container ship and quay crane simulator, and then this is the track 6. In this track 6, we also added this new function that would be interesting because it's not only about number of movements. You can now perform the total time the ship will spend in the container port by applying this quay crane rules. So you can return two things: number of movements and total time. It's up to you to choose between these two options, or you can combine them. So it's the reason why now we should modify the genetic algorithm that we made before, because now we have to account not only the number of movements but also the total time needed to perform unloading and loading operations by the ship. So we need to modify the genetic algorithm, and it's not just in the evaluation of if each individual in the population. You can use the decoder, but it's not only this, because the decoder will provide which unloading, loading, and quay crane rules you should apply in each port, but also after doing the simulation, you can extract number of movements and total time, so you could combine them to give some kind of fitness or how this solution is better or not than the other ones. So that's it, the main point that we're gonna address in this track number 7, and I hope you'll find this video interesting and useful. In the next class, we're gonna show what it should be modified in the code, in the Python code that we made in previously tracks. So it will be very simple, but it has some details that are very important to have a very good performance, to everything work in a good way. So thank you for your attention. I hope you find this video interesting and useful, and see you in the next video of this track. See you. Bye.